Hi folks, we're going to take a look at number 22 from page 93. So here they tell us that when this polynomial is divided by x plus k, the remainder is equal to 5, and they want us to find this unknown value k. So again, anytime we see a polynomial being divided by a linear divisor, and the only thing of interest is the remainder, this is where we should think of using the remainder theorem instead of actually doing a division. All right, so here we remember that what the remainder theorem says is that the remainder is equal to the polynomial evaluated at, well, if I'm dividing by something of the form x minus x naught, so in this case here, my x naught is going to be negative k, that the remainder is going to be given by p at negative k. All right, so now we're told that the remainder is equal to 5. And now we can input negative k into the polynomial. So 3 times negative k squared plus 10 times negative k minus 3. And we end up with an equation that we can solve. All right, so in this case here, it's a quadratic equation. So we may have more than one solution. So here, I'll bring 5 to the other side. So what do we have? Negative k squared is just k squared. So 3k squared. This is going to be minus 10k. And negative 3 minus 5 is negative 8. All right, so now we could use a quadratic formula, but I'm going to try factoring here. So I know that I'm going to have a 3k and a k in order to get the 3k squared. Okay, so here, my little trick of using the box to figure out what it is. So if I have 1 and 3 as my coefficients here, well, here I can have 2 and 4. Let's see if that works. All right, 2 and 12. Hey, look, that's going to give me 10. Okay, so it's going to be 3 times 4. We're going to make that one negative because it's the larger number. And then this is going to be plus 2. So negative 12 plus 2 is negative 10. And so here we can easily solve. This is going to be negative 2/3, or k can also be equal to 4. All right, and there's our solution. So it means that there's 2 possible values of k that are going to satisfy these conditions. So just to recap, I'm dividing a polynomial by a linear factor of the form x minus x naught. In this case here, my x naught was negative k. And so the remainder of this division is given by p at negative k. But since I was given the value of the remainder, it allowed me to solve this quadratic equation. All right, that's it for this one.